Wow, this jazz music sure is swanky. Oh, I hope they don't find us in the speakeasy here. More 20s phrases. Hi, welcome to another episode of Fantasy Joyride. So in this episode, we're going to talk about IR. What is IR? Why do I have jazz music playing? And why do I look like this? You're going to find out in this episode. All right. Stop, music, stop. Oh, perfect. Okay, so what is IR and why am I using it? So in forensic chemistry sections, specifically controlled substances sections, we need a way to identify drugs when they're pure substances in a very quick and easy format. Now, why am I doing that? Well, in drug analysis, we want to answer two questions. One, how much drug is present? And two, is there a drug present? So with the first one, with the first question, we answer with using a weight. So we're going to measure it, we're going to weigh it. But I'm not going to talk about that in this video. This is in regards to our second question, is a drug present? Now, in another video, I discussed the scheme that we have with analyzing drugs or possible drugs. But in this video, I'm specifically going to be talking about one of the instrumental techniques we have towards confirming the identity of drugs. This technique is called FTIR. Now, what does that stand for? That stands for Fourier Transform Infrared Spectroscopy. And you're like, oh gosh, an acronym, I don't want to know that, that's too much. Don't worry, we usually just call it IR, but it's technically referred to as FTIR. So what's going on? So I want to take you to my PowerPoint here. Perfect. Perfect. So what's going on? So in my students know that all, or at least a lot of forensic disciplines boil down to two steps. We have a screening step and we have a confirmatory step. The first step is, the first screening step is usually just to see, is something present? In DNA and biology, we test for blood or semen by doing a KM or an SAP test. And that's just to say, is blood or semen possibly present? Right? If it is, then we proceed to DNA analysis. But in regards to drug chemistry, this is usually a color test or a microcrystalline test. And that's just to tell us, is a drug there, and what kind of drug family is present. But for this video, we're going to talk about the boxed thing right here, confirmatory step, positively identifying the drug substance that's there. Now, in another video, I talk about another confirmatory technique called GCMS, which stands for gas chromatography mass spectrometry. And if you want to learn about that, that's really interesting. I relate it to a race with vehicles and like a crazy T-Rex like thing that destroys cars. And so if you're interested in that, that's awesome. So go to that video. But this is a different type of instrumental technique used to confirm. All right. So what is infrared radiation, you might ask? So if I could, there we go. Infrared radiation. Infrared radiation exists below the red visible light color wavelength. And you're like, visible light color wavelength, what the heck are you talking about? Well, all types of radiation exist in waves. And so you'll see here radio waves, which are very long, microwaves, which are getting shorter, and that proceeds all the way down to gamma rays. So you might think of like the Incredible Hulk with gamma rays. And contrary to comic books, gamma rays will actually kill you. They will not turn you green and give you all swole muscles. Although I wish I did. I wish I could just shoot my arms with gamma rays and I would like look like, I don't know, Chris Pratt or whatever. So when I talk about the visible light spectrum, I'm talking about this area right here. So we think of the visible light spectrum usually in terms of the Pink Floyd with the prism, where white light is hitting it and it splits into its Roy G. Biv, or red, orange, yellow, green, blue, indigo, violet. So white light exists in a spectrum, in colors. Well, just below that, just below red light, is infrared radiation or infrared light. So it's still a type of light energy, but you can't really see it. Okay? So infra meaning below, and red meaning red. So infrared radiation, it exists below red light. And the really awesome thing about infrared radiation is that we can use it to interact with chemical substances, specifically drugs, to give us a confirmation, because infrared radiation interacts with molecules in a unique way. In a unique way, it provides a chemical fingerprint that only that molecule of methamphetamine or that molecule of heroin will have. Okay? So the only caveat with FTIR analysis is that when we're analyzing something using this instrument, it must be pure. And you're like, pure? How do I know if it's pure or not? Well, that's why we usually do color tests. Color tests will usually tell us, is one drug present, or are multiple drugs present? Or it might even tell you there's drug present, but my colors are a little funky, so there might be something else at play here. So the only way to really tell if we have a pure substance is to put it on the IR and see what we're dealing with. So what's going on? So I want you to think of this candle here as IR radiation. You see those little lights? So that might be my IR radiation or my light source. All right? And we'll put the drug on the lid here, Yankee Candle, thank you. Copyright, I don't know. I hope I don't have to pay them now. Ooh, I don't got money for that. So what I'll do is I'll put my drugs on the top of my stage here, and I'll have my IR radiation interact with my sample. So, oh, I don't want to turn off my light. Perfect, there we go. So I'll put my sample on top, and then my IR radiation interacts with my sample up here. Now, what is the product of that is what you see here on your screen. It's called a spectra. And what is a spectra? It's just simply how the molecule is interacting with the IR radiation or the IR energy based on what chemical bonds are there. And you're like, oh my gosh, chemical bonds, what are you talking about? All that's really important is to say that different chemical bonds and different elements and how they're arranged on the molecule will affect how this spectra looks like. And then from there, we use this spectra to compare to a known standard. Now, a standard is a pure substance that we know is pure. It has no other drugs, no other gunk, no other fillers. We know that it's a pure drug. And so we can use our standard, our pure substance, and judge it based on our evidence submission, basically our unknown, and if the two look like they match and we see that there is enough similarity between the two, then we've made an identification. Now, I want to go back to pure substance. So why do I need a pure substance? And then for that, what I want, I'm going to stop the sharing here. What I want is I want you to go back to that jazz example. You know, I came in with jazz. I like to have fun and stuff like that. So jazz. So think of a jazz band, and I'm not super musically inclined, but in a jazz band, usually it forms where you have a pianist, a trumpet, a saxophonist, maybe a bassist, and just those four, maybe five people, and they'll play and they'll play, and each of those people will take a solo. They're going to take a solo. They're going to have their moment where the trumpet plays the trumpet, kind of freestyling, and then the pianist is going to freestyle on his own, and then the saxophonist, and then the bassist is going to go on their own. So they're each going to have their moment to shine. They're going to take the stage. All right? Remember, take the stage. So in a perfect jazz band, each of them is going to take it at a separate time. Now, in the jazz band that I'm thinking of, all the jazz members are so greedy. They're stage hungry. They want to take the stage for their own. And they're like, oh, I just want the spotlight. Now, what's going to happen when all those jazz members are going to play at the same time? And you don't even need to really think, because I can provide that sound for you. Just awful. It's just the worst. Yeah, I want to close all these tabs. Goodbye. Okay. You see how that just sounded so just discordant, just crazy? You know, you couldn't really decipher what was the trumpet, the piano, the saxophone, all that. You were hearing noise. Well, the same thing goes with IR, and if I put a mixture on top of my stage. If I put a thing of a sample that had methamphetamine, cocaine, and heroin and PCP, well, what's going to happen is my IR light source is going to interact with all four of those molecules, and my spectra are basically going to overlap with each other. Now, let me give you an example further of that. So here I have my FTIR spectra. I'm going to try and get the least amount of glare here. So I have my FTIR spectra. I haven't sampled anything yet. So what if I put in a sample of methamphetamine? Awesome. Cool. You can see that it's methamphetamine. You're able to understand it. It's great. Now, what if I were to put a sample of meth and cocaine and heroin on top? Come on. There we go. So meth, cocaine, and heroin. So you see here, meth is blue, cocaine is red, heroin's green. All right, so you can see that they're different colors. So you're like, okay, I can pick out the meth, I can see the cocaine, I can see the heroin. But the problem is that our IR, doesn't really pick them apart. We can't really tease all those people apart. So what we see is this. This is what we see. It is awful, it is gross, it is crazy. I can't really tell what does this belong to, what does that belong to, what is even going on over here. It literally looks like the cavern, like a mining cavern, and these are a bunch of stalagmites or stalactites. I don't know. I don't care. It looks like a bunch of garbage. So think of this as the 3 minutes ago when I was playing all of that jazz music all on top of each other. You can't really understand it. You can't analyze it. You can't make a confirmation from that. So when using FTIR, the big caveat, the big thing that's super important is that, come on, there we go. The big caveat is that it has to be a pure substance, because if it's not a pure substance, then I cannot identify that drug, and unfortunately, it's a pretty it's not entirely useless, but I cannot confirm anything using that instrumental technique. So until next time, guys, I hope that you enjoyed that. Just kind of think of IR as like a little jazz band, and if it needs to, if I want to use it, it has to be a soloist. It has to be a pure substance. Okay, guys, have a great day.